Okay, now next, Zener diode. This one, module 1 we have completed. We need to start with the module 2, and from the module 2, which topic they can give you, that is based on rectifier. Okay, so now we need to do rectifier. Rectifier is basically the application of the diode. One of the numerical, maybe the theory question or maybe the numerical question will definitely come from the rectifier. Rectifier is a device which is used to convert AC to DC. Okay, like suppose we are using socket at our home, right? We are using sockets now. So that socket is of which supply? AC supply, right? वो सॉकेट किसके होते हैं? AC सप्लाई के होते हैं. And we need DC supply. Suppose I'm giving you an example, like you are using laptop. Okay, so in the laptop you are having a battery, right? And wherever there is a battery, then in that case you need a supply in the form of DC, right? Battery के case में always you need DC supply, right? But from the socket we are getting AC supply, right? So in the laptop charger there is a device that is known as rectifier, which converts AC to DC. Okay, which converts AC to DC. Note it down. Now see, basically rectifier is divided into two categories. One of the rectifier is half wave rectifier, okay, and another rectifier is full wave rectifier. In the half wave rectifier, basically half of the waveform converts. Okay, like suppose this is the AC supply and you need to convert it into DC supply, so maybe either positive or negative supply will convert it like this. But in the full wave rectifier, both positive and negative cycle will convert. Okay. Now full wave is divided into two categories further. One is center tap rectifier, another one is the bridge type rectifier. Bridge type rectifier. तो पेपर में तुम्हारा एक क्वेश्चन पक्का आएगा, मे बी हाफ वेव से और मे बी फुल वेव से. इस बार भी आया होगा जो तुमने पेपर अटेम्प्ट करा था. न्यूमेरिकल था या थ्योरी थी? Like they are asking you the construction and working principle, both. Generally दोनों दे देते हैं कि theory plus numerical based on that. Okay, so what happens in the half wave rectifier? We'll use the supply, then after that we'll use transformer. Transformer is used to step down the voltage. Okay, it is used to decrease the voltage, and then we'll use diode over here, and with the diode they have connected the load resistance that is denoted by RL. Okay, understood? Now in the starting we'll give obviously the positive supply like this. Like this is the AC supply which we are giving to the waveform, right? This is the AC supply now. So first cycle is the positive cycle. Here will provide positive, this one would be positive, negative. So that means ki anode is connected with the positive terminal and this one is the cathode, and cathode is connected with the negative terminal, right? So as you already studied about the diode, that if anode is connected with the positive terminal and cathode is connected with the negative terminal, then in that case diode will work as a forward bias, and vice versa, that will be the reverse bias. In the forward bias current will flow, right? And in the reverse bias current will not flow. So tell me, for this particular case, diode will be worked as a forward bias or the reverse bias? Yeah, it is forward. So in the forward bias, current will flow, and if the current will flow, output will be there. Correct? Now move towards the negative cycle. If suppose we'll have negative cycle and positive. Negative cycle is this one, right? Negative, positive. That means anode is connected with a negative terminal. And if anode is connected with a negative terminal and cathode is connected with a positive terminal, then tell me, in this particular case, diode will work as a forward bias or a reverse bias? Reverse bias. And reverse bias, current will not flow. It will be zero. Again, in the positive cycle, current will flow, and again in the negative cycle, current will not flow. So this is how it will work. Okay. After that, we'll have full wave rectifier, right? So basically, in the full wave rectifier, first one, as I told you, that is center tap rectifier, and in the center tap rectifier, as its name suggests, that first will provide a supply as usual, then will provide a step down transformer. In the center tap rectifier, we'll use basically the two diodes, diode D1 and diode D2, and then in between load resistance is connected, and load resistance is exactly connected between the वाइंडिंग्स. ठीक है, लाइक सपोज ऊपर भी दो वाइंडिंग्स हैं, नीचे भी दो वाइंडिंग है, तो एग्जैक्टली ये सेंटर्ड में टैपिंग होती है. लाइक सपोज इफ यू हैव गिवन 100 वोल्ट, तो 50 वोल्ट ऊपर जाएगी एंड 50 वोल्ट नीचे जाएगी. या फिर इफ यू हैव गिवन 100 वोल्ट और वो कम होके 40 वोल्ट तक आ रहा है, तो 40 वोल्ट इज डिस्ट्रीब्यूटेड, ऊपर 20 वोल्ट जाएगी और नीचे भी 20 वोल्ट जाएगी. अंडरस्टूड? So now tell me again, will give provide AC supply with the positive cycle and the negative cycle. That is, Vs is the supply voltage. This would be Vs maximum, and this would be minus Vs maximum. Now in the positive cycle, which diode will work as a forward bias? D1, D2 or both? So in the positive cycle, D1 will work. In the negative cycle means negative here and positive here, negative here and positive here. So in this particular case, which diode will work? D1 will work or D2 will work? D2 will act as a forward bias or D1 will act as a forward bias? Okay. Now after that, we'll have next type of rectifier, that is known as bridge type rectifier. Okay, in the bridge type rectifier, did you remember the Wheatstone bridge? Yeah, in this case we'll draw the Wheatstone bridge like this, but in this case we'll use 4 diodes. Okay, like this. And here in between load resistance RL is connected. This is the supply voltage, right? Again we'll use transformer. This is D1, D2, D3, D4. Now you have to tell me that in the positive cycle and in the negative cycle, which diode will work? In the positive cycle, which diode will work? Tell me. So for the positive cycle, D1, no. For the positive cycle, this is positive and this would be negative. So in this case, D2 will work, right? And D4 will work. No. Sorry. This is negative. That means here at this particular side, D3 will work and D4 will work. And for the negative cycle means it is opposite हो जाएगा, तो this would be positive and this would be negative. D1 will work and D2 will work. Understood? Okay. Now see formulas based on numerical. Again, write it down on the last page as I told you. So in this case they can give you the numerical based on any type of rectifier, maybe the half wave rectifier, maybe the full wave rectifier, maybe the center tap, or maybe the bridge type. Okay, so first they can ask you the value for IDC. IDC is the output current, right? Because as I told you ki it converts AC to DC. Or they can say that average value of current. So they can give you by any form. IDC निकालना है, output current निकालना है, average current निकालना है. This one is for half wave rectifier. This is for center tap. This is for bridge type. तो half wave rectifier के केस में what would be the formula? I max by pi. Center tap के केस में 2 I max by pi, and bridge type के केस में again 2 I max by pi. Okay, clear? Now in the second case, if they ask you to calculate IRMS, IRMS is the root mean square. 12th में पढ़ा था ना, root mean square. So for this particular, हाँ, that would be I max by 2 for half wave rectifier, I max by root 2, and I max by root 2 for the bridge type. Next they can ask you the peak inverse voltage. Okay, peak inverse voltage is also denoted by PIV. So for this particular case, PIV is VS maximum, that would be 2 VS maximum, और इस केस में VS maximum. ज्यादातर यू कैन सी कि ये सेंटर टैप और ब्रिज टाइप सेम होगा, बट यहाँ पे ये ध्यान रखना PIV पीक इनवर्स वोल्टेज की वैल्यू इसमें अलग है. रीजन, क्योंकि सेंटर टैपिंग होती है उसमें वोल्टेज इक्वली डिस्ट्रीब्यूट हो जाता है, तो मैक्सिमम वोल्टेज उससे डबल जाएगी. ठीक है. Next is rectification efficiency, that is most and most important. Rectification efficiency, efficiency का symbol ये होता है. So for that the formula, half wave rectifier के केस में generally it would be 40.6%. For full wave के केस में obviously full wave है तो इसकी efficiency ज़्यादा होगी. And इस केस में क्या formula होता है? 0.406 divided by 1 plus RF by RL. What is RL over here? Load resistance. RF is the diode resistance, forward diode resistance. Yeah. तो generally diode resistance नहीं दिया होता तो you can consider and then की value से vary कर जाएगा. अगर नहीं दिया होता तो your value should be 40.6%, और वो तुम्हें निकाल के दिखानी, show करनी होगी. Okay, you can't directly write down की efficiency होगी. Now for this particular case it would be 0.812 divided by 1 plus 2 RF by RL. It would be 0.812 divided by 1 plus 2 RF by RL. ठीक है? Understood? Or you can get efficiency by using this formula कि वो तो तुम निकालोगे VTC, अच्छा हाँ वो तो तुम निकालोगे ही, लाइक एक स्टैंडर्ड फॉर्म में बता देती हूँ. लाइक एफिशिएंसी इज व्हाट? आउटपुट पावर डिवाइडेड बाय इनपुट पावर. करेक्ट? सो आउटपुट पावर इज हाउ मच. जैसे ये तो तुम्हें पर्टिकुलर याद करना पड़ेगा, यू डोंट नीड टू राइट इट, रिमेंबर इट. आउटपुट पावर इज व्हाट? V square by R, right? Input power is also V square by R, right? So if no RF is given, output in the form of DC, तो ये कितना हो जाएगा? VDC का square. And input power is always in the form of AC. So what we can write down? V square RMS by RL. ठीक है? Next, they can ask you the ripple factor, and ripple factor is denoted by gamma. ठीक है? Ripple factor is denoted by gamma, and gamma का formula is root of IRMS डिवाइडेड बाय IDC का होल स्क्वायर -1। इट इज सेम फॉर एवरी केस, क्योंकि ऊपर से RMS वैल्यू वेरी कर जाएगी। IDC निकालना, IRMS निकालना, देन यू विल गेट द रिपल फैक्टर। ठीक है, अंडरस्टूड? इट विल सेम, फॉर्मूला सेम होगा। ओके, नेक्स्ट इज दे कैन आस्क यू VDC। तो VDC एज यू नो अकॉर्डिंग टू ओम्स लॉ, तो ये याद अलग से नहीं लिख रही मैं, यू नो कि VDC होगा तो IDC इंटू RL होगा, राइट? IDC you already know, right? Similarly, they can ask you Vmax, तो Vmax is similar Imax into RL, ठीक है? One more thing that you need to remember, the standard equation, as you know, ये तुम्हें BT में भी पढ़ोगे वैसे, that V is equal to Vmax sin omega t. This is the standard equation of voltage और करंट की भी। तो क्या करते हैं क्वेश्चन में, कई बार they'll give you in the equation form, like suppose they'll give you V is equal to 230 root 2 sine of 2 pi t, ठीक है? So from here can we compare this equation with this equation? So for what we'll get, V max would be equal to 230 root 2, right? And tell me the value for omega. Omega is 2 pi. Okay, understood? And one more thing you need to remember for this, first write it down, this formula. Rectifier question they can give you in the form of transformer ki turn ratio. Okay, like suppose they have given ki turn ratio is 10:1. Okay, they'll give you 10:1 ki ratio hai. So if you'll provide 230 volt over here, can you tell me how much will be the voltage in the secondary side at this particular side? 23. See how it will work. This is primary turns, that is denoted by N1. This is secondary turn, that is denoted by N2. This is primary voltage, that is denoted by V1. And secondary voltage, suppose we need to calculate. So we'll have particular formula for that. What was that formula? That V2 by V1 is equal to N2 by N1. So that would be how much? N2 by N1 is 10 by 1 multiplied by, no, sorry, 1 by 10 into 230. So that would be 23 volt. Okay? Clear? Okay. One more thing, write it down over here only. It will be on the same page then. Sometime they'll ask you the output frequency. Output frequency is denoted by F. For half wave rectifier, it would be the same as the original frequency F. For full wave rectifier, it will be the double, twice of F. Okay? Okay. Now, see, whenever you will use rectifier, then we don't get a smooth output DC. Like as you have seen, we are getting output like this, right? But what we want, we need output of DC like this now. So this is a small kind of ripples, and we need to remove. In this case, we want pure DC, है ना? So for pure DC, we need to remove this ripple. For that particular purpose, we'll use filters. Okay, so इस केस में हमारे पास filters का will have particular formula. Write down the heading filters. Again उसी formula में ही लिखना है, filters with rectifier. तो VDC का formula is 2FCRL into VM. VM is the maximum voltage. 1 plus 2FCRL. ये तुम्हारा शायद हैंडबुक में गिवन है, एक बार फिर भी क्रॉस चेक कर लेना. This is for particular half wave rectifier. Next, for the full wave rectifier, it is 4FC RL VM divided by 1 plus 4FC RL. And if they ask you the gamma, यही दो पूछते हैं. Gamma means the ripple factor. That would be the formula 1 by 2 root 3 FCRL. And for this one, 1 by 4 root 3 FCRL. Okay. So this is the question from your recent paper 2024 December वाले पेपर में से है ये. This is, they said, a center tap full wave rectifier is connected to a transformer with a turn ratio of 10:1. So what they have given turn ratio कितनी दे दी, 10:1. ज़्यादातर यही देते हैं. Then they have given the input AC voltage to the primary winding 2 is 220 volt. Means V1 is how much? 220 volt. And that too they have mentioned कि it is RMS. नहीं भी mention करेंगे तो automatically we need to understood it is RMS only. Maximum नहीं होगा वो कभी भी. Until and unless they mention. ठीक है. जो भी ये वोल्टेज देते हैं वो हमेशा कौन सी वोल्टेज देते हैं? RMS वोल्टेज देते हैं. Until and unless वो इक्वेशन की फॉर्म में न दें. इक्वेशन की फॉर्म में तो मैंने बताया था वो क्या देंगे? मैक्सिमम. नेक्स्ट इज लोड रेजिस्टेंस. लोड रेजिस्टेंस इज 1 kilo ohm. Assume the diodes are ideal. Find, हमें क्या क्या निकालना है? Peak output voltage. Peak means maximum, right? तो आउटपुट है तो सेकेंडरी साइड पे होगा और आउटपुट है तो डीसी होगा, राइट? सो बेसिकली व्हाट वी नीड टू कैलकुलेट, पीक आउटपुट वोल्टेज अक्रॉस द लोड. ठीक है. Then we need to calculate average output voltage across the load. Means we need to calculate VDC, we need to calculate Vmax, we need to calculate PIY. अब ये इन्होंने मॉडिफिकेशन कर दी, देखो कि अक्रॉस द लोड निकालना है. जनरली लोड के अक्रॉस पूछते नहीं है, बट इन्होंने लोड के अक्रॉस पूछा है. तो लोड के अक्रॉस के लिए तुम्हें क्या करना पड़ेगा? VDC must be equal to IDC into RL होगा ना. एंड अगेन VI max into RL. कैलकुलेट करो अब एक बार. So in this question V1 is given, right? We need to calculate V2. That would be 22, right? फॉर्मूला यूज कर लेंगे, 10 से डिवाइड कर दिया. So that is V2 is V2 RMS, correct? Now you need to calculate V2 max. PIV उसके इक्वल होगा मैक्सिमम के. So what is the relationship between the V2 RMS and V2 max? क्या होगा मुझे बताओ? V RMS would be equal to V max by root 2. तो V2 max बताओ मुझे अब क्या हो जाएगा यहाँ से? So for this case VDC is how much? VDC is 2 Vmax by 5. 2 we already know. Vmax is how much? That is जो हमने अभी निकाला है 22 root 2 divided by 5. Okay. They have given V2 RMS is 12 volt. The RMS value of the voltage at the secondary transformer. Secondary है तो 2 और RMS तो रहेगा ही, right? और if the diodes are ideal, turn ratio of the transformer हमें निकालना है. और V1 RMS कितनी हो है? 220 volt. तो तुम्हें फॉर्मूला पता ही है, N2 by N1 is equal to V2 by V1, right? तो यहाँ से टर्न रेशियो आ जाएगी. अब DC output voltage means VDC. VDC is how much? Half wave rectifier है तो V max by pi. If we know VRMS, we can get VR max. क्या रिलेशन होता है? VRMS is equal to V max by root 2. Now they are asking DC power delivered to the load. Means PDC they are asking. राइट। सो PDC इज I स्क्वायर R, है ना, I स्क्वायर DC इंटू RL। तो IDC यू कैन गेट इट। IDC का क्या फॉर्मूला होता है, I max बाई पाई, है ना, एंड V max पता है, RL पता है, तो I max भी आ जाएगा बाय द फॉर्मूला V max इज इक्वल टू I max इंटू RL। यस और नो?